Welcome to Mrs. Thomas's Common Core Math videos. This is lesson 9. We're solving algebraic equations using tiles, and those equations contain division. All right. If you have watched the other videos, we have already solved algebraic equations where there was addition. The variable was added to some ones. Where there was subtraction. There was a variable, sometimes positive, sometimes negative, and then there were ones, positive or negative. We've solved for a variable using multiplication, and that's when we have groups of the variable. So 2x is two groups of x. We have two x's. Here we have x divided by 2. Any ideas? How can I show that with my tiles? What does x divided by 2 actually mean? It means we have an x that's been divided into two groups. How can I divide an x into two groups when I only have one of them? Oh, we're going to need scissors. So we're going to take this x, and as carefully as possible, I'm going to cut it. What do you think? Is that half? I'm going to cut it in half. X divided by 2 means we just have half of an x. We have one group of x that's been divided into two pieces, and we only have one of them, right? And then on the other side, we have 4 ones. Oops. 1, 2, 3, 4 ones. Okay, so what do you think we're going to need to do? Remember, our goal is to isolate the variable. We want the variable to be positive, and we need a whole variable. We can't have a little piece of a variable. So a hint, if you're not sure what we're going to do next, is that this is a variable divided by 2. And if we're going to undo this to get a whole variable, we're going to need to do the inverse of dividing. Do you guys know that the inverse of dividing is multiplying? So we're going to need to multiply both sides of my equation. Again, this will always be true, whether you get all the way to calculus or not. Whatever you do to one side of the equation, you're always going to do exactly the same to the other side. So since I'm multiplying this by 2, I'm multiplying this by 2. And this 2 means I need two groups of this, right? I need two groups of the size x divided by 2, of half an x, basically, right? Over here, I need two groups of 4. There's one group of 4. And there's my second group of 4, right? Two groups of 4. And so here, I can put together my two pieces. Wait a minute, like that. And I get one whole x all by itself. And that's what I wanted. I wanted a whole x that's positive. And on this side, my two groups of 4 ones ended up giving me 8 ones. And that's my answer. All right, we've got -3 equals x divided by 3. So -3, we know, is 3 negative ones. X divided by 3 isn't that complicated. It's an x, right? Here's one whole x. And I've already cut it up into 3 equal pieces. Can you see how many of these pieces I'm going to have? I'm just going to have one. Interestingly enough, x divided by 3 is the same as 1x divided by 3. We have 1x divided into 3 pieces. So I got this little piece of an x. If you start cutting up your algebra tiles, it's a good idea to label them. If you cut them up a lot, sometimes it's hard to tell the difference between the different pieces and which ones go together. So I labeled this one. You might be able to see it says 1/3. So I've got 1/3 of an x, and I've got 3 negative ones, and I want one whole x. So I'm going to have to multiply both sides of my equation by 3. The inverse of dividing by 3 is multiplying by 3. 3 means 3 groups of this. So I've got 1, 2, 3. 3 groups of x over 3 gives me one whole x. So that's what I have over here now. I have one whole x. And 3 groups of -3 and I can count those all up, and that's 9 negative ones. So I get x equals -9. Negative 9 equals x, same thing as x equals negative 9. How about this one? 2x over 3 equals 4. That looks a lot more complicated, but it's not. I know the size of my pieces. Anytime I have a number in the denominator, that's what I've cut things up into. So the size of my pieces are thirds, right? But this up here is how many pieces I have. When I just had this, I had one piece. The size was thirds. Now I have two pieces. The sides are thirds. I have 2/3 of an x. So 2x over 3 is exactly the same thing as 2/3 times x. 2/3 of x is the same thing as 2x over 3. And if you can go back and forth between these, sometimes this makes the math easier, and sometimes this makes the math easier. It's really good to recognize that these are the same. Do you want me to prove it to you? I'll do that when I'm done with this problem. All right, so I got 2x over 3. So I got my two pieces, size 1/3 x. Over here, I've got 4 positive ones. 1, 2, 3, 4. How am I going to get 1x all by itself, right? Well, I've got two options. I've got two things happening to my variable here. Can you see that? My variable is being multiplied times 2. I have 2 groups of x. At the very same time, it is being divided by 3. So I have the size of my pieces are thirds. I need to undo both of these. I don't have to do it at the same time. Most students want to get rid of this 3 first because they don't like fractions, and that's fine. Let's get rid of the 3 first. 2x is being divided by 3 here, so let's multiply both sides by 3 so I can get 2 whole x's on this side of the equal sign. All right, so I've got 3 groups of this, right? Of 2x over 3. Here's 1 2x over 3, 2 2x over 3, 3 2x over 3. And I've got 3 groups of 4 ones over here. Do you see that I could rearrange these to make 2 whole x's? Yeah, and that's because when I multiply 3 times 2x over 3, I get 3, let's make it into a fraction. When we multiply fraction, or whole number times a fraction, right? We make the whole number into a fraction. I've got a 3 in the numerator and a 3 in the denominator. The 3's cancel. 3 divided by 3 is 1. And 1 times 2x is 2x, and that's why I end up with 2 whole x's here. I have 3 groups of 4 over here, and everybody should see that that's just 12. 12. So now I don't have pieces anymore. I'm actually going to replace these because they're hard to move around because this is the same thing. So what I actually have is 2x equals 12. Nice, huh? This looks a lot more friendly than this does. So you can get rid of your denominator every time, and this is why the equal sign is so nice. You can always get rid of the denominator by just multiplying by whatever that is. You're undoing the division with multiplication. The inverse of division is multiplication. All right, now I've got 2 x's equals 12 ones. I only want 1 positive x, isolating the variable. So I'm going to do the inverse of multiplying by 2. I'm going to divide by 2. 2 x's divided by 2 gives me 1x. And 12 x's, 12 ones, excuse me, divided by 2 gives me 6. So x equals 6. All right. In the previous example, I made the claim that these are the same thing. And I like to back up my claims with a little mathematical proof. Okay? So I'm saying 2 times x divided by 3 is exactly the same thing as 2/3 times x. Well, I can show you this. We'll leave this one alone. This one, I'm going to use my multiplication skills and fractions to turn it into this. So whenever I multiply a fraction times a whole number, or a number that's not a fraction right now, you got to get used to just using this variable like a number. Anything you can do with a number, you can do with a variable. So I'm going to change this to this. These are the same. 2/3 times x is the same thing as 2/3 times x over 1. Everybody agree that x is the same thing as x over 1? Yeah, exactly the same thing. No matter what this number is, if I divide it by 1, it stays the same. It's the same number. All right, my rules of multiplication say multiply the numerator times the numerator and the denominator times the denominator. So 2 times x is 2x and 3 times 1 is 3. Look at that. Booyah. Exactly the same. Here's one for you to try on your own. Pause the video, give it a try, restart the video. Let's see how you did. Okay, x divided by 2, that's a half of an x. So I got my half of an x right here, and I've labeled it a half so I don't confuse it with my thirds. And over here, I've got 1, -1. So half of an x equals a -1. I want a whole x. I want to undo dividing by 2. I'm going to use the inverse of dividing, and I'm going to multiply. When I multiply by 2, remember that you're going to say, well, that's 2 divided by, or 2 over 1, so that you're multiplying the numerator times the numerator and the denominator times the denominator. And if I have 2 groups of x over 2, that's just 2 halves. 2 halves. And 2 halves make 1 whole x. Beautiful. Just what I wanted. On this side, I have 2 groups of -1. 2 -1s make -2. So x equals -2. Give this one a try. All right, you got 6 positive 1s. You've got x divided by 2, so the size is going to be half of an x. And we've got 3 of them. 1, 2, 3 halves of an x. I want 1 whole x over here. Let's get rid of the 2 in the denominator first. So if I want whole x's instead of half x's, I need 2 groups of this. I'm undoing this dividing by 2 by multiplying by 2, both sides. So I get 3 times x times 2 divided by 2 times 1. 2's cancel. If I have a 2 in the numerator and a 2 in the denominator, 2 divided by 2 is 1. 1 times 3x is 3x. Here's my 2 groups of 3x over 2. So I had half x's, 3 of them, and now I've got 3 more of them, 2 groups. Here I had 6 1s, and now I've got 6 more 1s, 2 groups of 6 1s. I got 12 over here, and I can put these together and make 1, 2, 3 whole x's, just like I did with the math up here. 3 x's on this side, 12 1s on this side. So I've got 3 x's, I only want 1 x, 3 groups of x. The inverse of multiplying by 3 is dividing by 3. I'm going to divide this into 3 groups, and I'm only going to keep 1 of them. I have 12 1s, and since I divided this side by 3, I'm going to divide this side by 3. So when I divide my 12 1s into 3 groups, I can see each group contains 4 1s. So I get x equals 4, 4 equals x equals 4, same thing. Here's another one for you to try. X divided by -3 equals -2. X divided by -3, as I cut this positive x into 3 groups, this negative sign says take the opposite. So I end up with a -1/3 of an x. Here I've got 2 -1s. Does everybody see I need 3 groups this size? So I'm going to multiply both sides by 3. So I've got 3 groups of 1/3 x. And I've got 3 groups with 2 -1s in each group. So I get -x is equal to -6. I want a positive x, so I need to take the opposite. So if -x equals -6, when I take the opposite of -x, I get positive x. When I take the opposite of -6, I get +6. X equals +6. Here's a math tip for you. This is kind of a shortcut. I'm not a big fan of shortcuts. but you're probably going to see this in your math class. I like to do this in 2 steps until you're really comfortable with it. Think about multiplying both sides by 2 to get rid of the 2 in the denominator that's being divided. And divide both sides by 3 because 3 is being multiplied times x. But you can do both at the same time. You're going to see this. Multiplying both sides by 2/3. Do you see that when I put this 2 in the numerator here, I'm actually multiplying by 2? If this wasn't here, this would be multiplying 3x over 2 by 2, which is the inverse of dividing by 2. And this 3 here, by putting a 3 in the denominator, I'm multiplying 3x over 2 by 1/3. Well, that's the inverse of multiplying by 3. Dividing by 3 is the inverse of multiplying by 3. So when your teacher tells you, oh, you should just multiply by the inverse of the fraction, she's saying in 1 step, you can divide this expression by 3 and multiply this expression by 2 by multiplying by the fraction 2/3. And I get 3 times x times 2, right, when I multiply across the top, and 2 times 3 in the denominator. On this side, I get 2 times 6 all over 3, multiplying the numerator times the numerator, denominator times the denominator. And here, I wouldn't multiply and then simplify. I really like leaving it as factors and saying if I have a 2 in the numerator and a 2 in the denominator, they cancel. They equal a 1. 2 divided by 2 is a 1. Remember, 1, 2 has to be in the numerator, 1 has to be in the denominator. 3 divided by 3 is 1. And x divided by 1 or x times 1 is still going to be x. It's going to keep its identity. And over here, I got 2 times 6, which is 12, and 12 divided by 3 is 4. So this is the shortcut. I wouldn't start doing this until you feel really comfortable doing it in 2 steps.